Hello everyone, welcome to another video on Shellcoding on ARM Assembly Linux 32-bit course presented on YouTube. So in this one we are going to talk about the CPSR register in depth and the ARM instructions which we are going to encounter in this entire playlist. Talking about the CPSR or current program status register is a 32-bit register which stores some values which have some significance in them, which is used to make choices in our program. By the values of CPSR register we can just know many things about the program which is currently getting executed by the processor. So this register is used to just provide a status of the program which is getting executed by the processor. Talking about the details of all the bits in the CPSR register, so from bit 0 to bit 4, or we can say 5 bits, first 5 bits are used to represent the mode the processor is currently getting executed in. So talking about the modes that ARM processor support is the user mode, FIQ, IRQ, and this SVCE, which we know a lot, supervisor mode. So all of these modes are supported by the ARM processor. We can easily identify the length of the bits which are used to just represent the mode is of 5 length. So by this we can just easily identify the first 5 bits stores these values, which is used to represent the mode of the processor. Talking about the next bit or the fifth bit, it is the T bit, which is used to represent that what the program is currently getting executed in. Is it in ARM mode or thumb mode? If it is 1, then the program is getting executed in thumb mode. If it is 0, then it is getting executed in ARM mode. The next subsequent 6, 7 and 8 bits are of FIQ, IRQ and abort disable bit. So you can just easily identify the modes FIQ, IRQ and abort. So whenever the mode FIQ, IRQ or abort is set in the first 5 bits, these bits are also updated to just represent separately what the current mode of processor is in, if it is in FIQ, IRQ or abort. Talking about the 9th bit or the E bit, or we can say Indianness bit. So many of you may not know, like ARM can execute binaries of both Indianness. ARM is a bi-Indian processor, which means that any binary created for Little Indian architecture can also be executed by ARM processor, and any binary created for Big Indian architecture can also be executed by an ARM processor. So it is a bi-Indian processor. By the value of 9, we can just easily identify the Indianness of the program. Talking about the next set of bits from 10 to 26, these are reserved bits. We can just see these bits and we are not able to use these bits in our program. So talking about the next bit or the 24th bit is the Jezal state bit. If you just code your program in Java, then you know you need to just have a JVM utility or Java virtual machine by which your Java bytecode gets executed on your host environment. So what this J provides is ARM processor supports Java bytecode execution from its core. So if you are using ARM processor and just coding in Java, you don't need to just have a JVM because the processor itself supports execution of Java bytecode. So there will be no requirement for JVM stubs to execute Java code on ARM processor. That's why all of the Android applications are built on Java and are incredibly fast, because the ARM processor itself supports Java bytecode execution. That's why the processing power of the Android apps is fast. Talking about the next bit, 27th bit, is Q or C flag. So it is a saturation overflow. I will just explain you in depth about this in later videos. Talking about the 28, 29 and 30 and 31 bits, or the last 4 bits, are the NZCV bits. N stands for -0 and Z for 0, C for carry and V for overflow. So these are all the bits which are present in the CPSR register. All the details are just displayed here. So how the values of the CPSR register are updated. So if you want to set a negative flag or the 31st bit, you have to perform an operation which just results in a negative number, like subtracting 2 with a 3 creates a -1. So the negative flag will be set. Likewise, if your program produces multiplication with the 0, or we can say result 0, then the 0 flag will be set. If your program just provides or creates a carry, then the carry flag will be set. If your program creates an overflow, like the number of bits which are used to add or subtract or operate exceeds the size of initial bits, then the overflow flag will be set. As you can see here, like we are using 4 bits with 4 bits addition, and the result is 5 bits. So one overflow bit is added. So that's why overflow flag will be set. The Q and saturation flag are used to just identify the final result and result of multiple multiply operations. So this is less used in our program, so we are not going to use it anyway. You can just search about this on the ARM documentation. The next T bit is thumb bit. So the thumb bit is set only if we just change from ARM mode to thumb mode. We are going to see how to just change our program execution from ARM mode to thumb mode in the later videos. So stick with the playlist. So talking about the types of instructions that we need to understand, that we need to know, are the move instruction. Please don't underestimate, like we are going to just learn about only just moving the values here and there. There are tons of variations we can use with move instruction, so don't underestimate what we are going to learn in the next video. Load store instructions, arithmetic, logical, branch and stack instructions will be a part of this playlist. So you will get to know everything about what are load and store instructions, how to use arithmetic instructions in ARM assembly, logical instructions, branch and stack instructions too. There you can see a special instruction which I have just represented, the IT instruction. So it stands for if then instruction. So if you want to just create any kind of conditional execution, like if a is equal to 2, then do this, else do that. Like if you want to do conditional execution, you can just use the IT instruction. We are going to cover this in a separate video, don't worry. So that's all for this video. Meet you on the subsequent one, because learning about all the instructions in a single video will not benefit you. So all of the instructions I have represented needs a separate video to just provide you a proper guidance, provide you a proper explanation. So that's all for this video. If you have any question related to this video, you can just simply ask in the comment section. The query will be resolved within an hour or two. You can download the slides used in this video from the description below, where you can, from there you can follow me on my Twitter and GitHub as well, and follow me as well. So that's all for this video. Meet you in the next one.